Hello and welcome to Tim's BMW Repairs and Information. Yep, I mean this car's getting on a bit now, isn't it? What, 24, 25 years old? Yeah, made in 1998. And as the cars get older, all sorts of things go wrong with them. I mean my 6 Series, which is just sitting there, that goes wrong all the time, but not the engine or anything like that. It's just sort of bits and bobs fizzle out, soft tops, nothing but trouble. Headlights get all misted up and things like that. But there's one thing in both these cars that you never check, never goes wrong, but it never does anything. Well, unless you have an accident. Of course, that's the SRS module, which is the Supplementary Restraint System module, the one that runs the airbags. Now, in the earlier cars, like the first E31s, didn't even have one. No, they had crash relays in the front there, underneath the bonnet or hood. Yeah, hood. And yeah, if you had a crash, then they would put the hazard warning lights on and a few other bits, unlock all the doors, of course, so the rescuers could get you. And that's about it. Now, some early models came with an airbag, but it was a single airbag as part of the steering wheel. So all the electronics of the whole supplementary restraint system was in the steering wheel. By the time the 840 was introduced, it was SRS as standard with a complete SRS system. Well, I say a complete. The driver got an airbag, the passenger didn't. And it wasn't until a bit later that the passenger got his own airbag. But interestingly, those without airbags ended up with 2 glove boxes, an upper one and a lower one. And I have seen these cars modified so the upper airbag is removed and replaced by the glove box, with the usual sort of excuse saying, well, I doubt if the airbags are going to go off anyway. Fans staying in the fast lane now, and that's annoying the Tesla driver. Jolly good. Yeah, unfortunately we're not going to make it past 1 Series, much too slow. First of all, how are you going to be absolutely sure that the airbags are going to go off? Well, the reason for that is they're designed in such a way that they're absolutely sure to go off. Now, the airbags themselves are obviously pyrotechnic. They've got an explosive element in there that then ignites a charge, which rapidly expands an airbag and obviously moves this bit out of plastic out of the way and so on. Yeah, but sure, it could get dampness in there and it wouldn't work. No, you can't. No, they're sealed. They're ceramic. So the inside is ceramic coated. They're absolutely airproof. So no air gets in them. No air gets back out of them again. 100% sealed so that the pyrotechnic compounds in there will fire. I mean, it's a bit like a World War II bomb. Yeah, you can still dig them up and blow yourself up with them. That's for sure. So you can be absolutely sure that this airbag is going to fire if the right sort of electricity goes to it. Okay, Tim, well, what about the wiring? Yeah, I mean, the wiring could be old and mouldy. I mean, this E31, for instance, has biodegradable wiring in them. How can we be sure that it's going to work? Well, first of all, the outputs to all the airbags is isolated from the chassis of the car. So the 2 wires that run to a single stage airbag like this one aren't joined to ground, aren't joined to 12 volts. They're only joined to the SRS module, the one in there. And if there's any chafing or if there's a breakdown of insulation and it shorts the chassis, SRS module knows that. It'll put up an error on the dashboard. Now, those sort of errors are very few and far between. The wiring between the SRS and the airbags isn't biodegradable. Okay, so how does the SRS module know that this airbag is here and is going to fire? Well, the airbag, the pyrotechnic device, has a certain electrical resistance, and that's measured by the SRS module. So that the SRS module knows that the wires have gone all the way to the airbag. They're intact, they're not chafed, they're not shorting to the chassis anywhere, and they know that if they put the right amount of electricity in them, they're going to fire. Now, I've heard it on so many forums saying, yeah, I swapped the steering wheel and, yeah, I've put a dual stage airbag in instead of the single stage. how can I stop getting the errors? Well, first of all, don't worry about the errors. If you hit something, you're going to be dead. Your face is going to be caved in and your nose flat on your face. Yeah, that's brilliant. Yeah, stick a resistor in there and everything's great. The light doesn't come on, blah, blah, blah. Yeah, we don't mess about with airbags. We really don't. We have them so they work. Yeah, and I've heard it said, well, in the old days, we used to drive about without any airbags. Yeah, that was in the days when cars were doing 50 miles an hour on roads. Now we're doing closer to 100 miles an hour in both directions. You hit one coming the other direction, you've got a speed of about 160 miles an hour as you hit each other. Yeah, you wouldn't have survived it in an Escort in the 1960s, but in a BMW of this vintage, with all the airbags in place, you've got a good chance of surviving it. You won't know if you put a resistor in it. Yeah, don't think of yourself as being really clever and smart for sticking a resistor in it, especially when you sell the car to someone else. You are now getting to the point where you're a murderer. Yeah, so think twice about swapping airbags for incompatible ones. You can't stick a dual stage airbag on a single stage car. You can't stick a single stage airbag on a dual stage car. They're completely incompatible. Now, the dual stage airbags work completely differently. They have two elements in them. One has a smaller charge, one has a larger charge, and you can fire the smaller charge on its own, and fire the bigger charge on its own. You can fire them both together. You can fire one and then the other. You can fire the other and then the one. And it will do it in such a way that you're protected to the greater extent. They have spent absolutely years making sure this is absolutely perfect and is going to save you. So if you go around sticking a resistor in instead of an airbag, you're just an idiot, let's face it. And never sell a car on where you've stuck a resistor in it. It's absolutely ridiculous, it really is. Next thing is electronics. Now, I said the SRS module is down here, and there's a good reason for it being down there, is that in most crashes it won't be damaged. So it's perfectly safe right in the middle of the car here under the centre console. The other question is, how does it fire the airbags without a power supply? Because that can happen, you see. If you get rear-ended, it could damage both of the batteries. Your 12-volt system goes off, but the airbags have still got to fire. And now that's because it stores energy in it. And that's going to be really interesting when we take an SRS module apart to find out exactly what's in one that can actually fire all the airbags. Can't be a battery because they don't last long enough. Everyone knows with the sirens in these cars that the siren battery fails and then the siren goes off and all the rest of it. So it can't be a battery. Could it be a big capacitor? Well, it could be a big capacitor, but as we know with the general module, the capacitors do fail. So what is in it? And that's what we're going to find out. And we're going to find out how the SRS module is made in such a way so that it survives the impact and still saves the occupants of the car. Okay, let's get it into the workshop. The colour always signifies that it's an airbag, so it's this orangey colour. So all connectors you find in your car which are orange, that means it's part of the SRS system. There's a very compact assembly, and it also gives you an attention warning that this can only be used in the car that it was intended for due to the programming in it. And it will need to be reprogrammed if it was moved from one car to another. But they warn against it. Also notice how secure the fixings are. It's got three fixings, and they're castellated as well, so they're not going to come loose. That's very important because it's got to measure the G-forces of the car, and if it's loose and rattling around, it'll measure its own G-forces. And these two green spots here notify the service engineer that the software's been updated at these two times. Right, I wonder where it comes apart. Well, I think it's coming apart already, so that's good. Base plate, back side of the PCB, so it's only populated on one side, and that's quite a heavy construction. That's a cast aluminium or cast alloy piece, so that's tough old stuff. Right, and there it is, an SRS module. Yeah, it's very interesting. I've already mangled it to a certain extent so we can see what's going on. You have mangled this device, which is an accelerometer. And you can see exactly how it works. It's got a bit of ferrite in there. It is magnetic. And if you hit something with going this direction, of course this will stop and the ferrite will keep on going. And yeah, it'll go over this end. And I should think there's a Hall effect device, a magnetic device, that gives an analog output from this thing to determine how far it went. And then decisions be made whether it fires or not. But that's done at the same time. Also, I do a bit of slow-mo for this so you can see what this does when I hit it against something hard. It measured in concert with these two. These are two more accelerometers. And you can see they're 45 degrees to front back and 45 degrees to left right. So they can measure forces coming from the left or the right or front and the back. And what they'll be used for is to make absolutely sure that if this gives a signal at a voltage which determines you've hit something, these are going to make absolutely sure you're not telling fibs. So they're both accelerometers and they're both piezoelectric devices. I have a wafer of piezo crystal in this axis here with a little sensor front and back, and same on this one. It has a wafer of piezoelectric material with a sensor front and back, so that can measure acceleration or deacceleration in this case, obviously. So yeah, 3 accelerometers of different varieties, a very basic mechanical one, very unlikely to go wrong. The only likelihood is the Hall effect device, the magnetic sensor underneath it might have gone wrong, in which case the system relies on these two giving corroborative evidence. Okie doke, so that's the main thing, 3 accelerometers. Other thing is storing the enough electricity to fire the airbags, and that's what these 4 are for. 2 channels, it's those 2 there for the passenger, those 2 there for the driver's airbag. They're 470 microfarad at 35 volts. Of course, you're never going to reach 35 volts, but you are, because we got a buck boost regulator. I think it's this IC and the big inductor, and that will boost the voltage up to 30 volts, so we can store more energy on these capacitors. And it's energy that fires airbags, not voltage or current, but joules, and it's a 0.1 of a joule is required to fire an airbag according to the data sheet that I've seen. And they, as I say, they use pyrotechnic devices to fire the charge, and they can go right down to 0.1 of a joule to fire it. So we store many times more energy on these capacitors than 0.1 of a joule, so we can be guaranteed that if we bung this electricity into the device, it's going to go off. Okie doke, so that's the storage of the power that we need in joules, and that's the ones which take a while to discharge. Or is it? No, I don't think it is. I think it's this pair here. This pair here are for the rest of the electronics of the system, and they provide enough power or enough energy storage along with its little switch mode regulator, and that's the inductor for it down there, to keep these 2 going, which is the main processor, that one there, that's a Motorola processor running at 16 megahertz, and that's its little, I think it's a resonator on this actually, it says 16 on it, so that'd be 16 megahertz. So yeah, that's the main processor, Motorola. That, yes, that's a bit of a mystery, but I'm guessing the function of it is manifold, and it's specific for SRS modules, and do notice it's got the green blob on it, same as we got on the connector, and so that will show its software level, I would have thought. As I say, there's very little information to be found on SRS modules. The Russians like playing with them, I'll give them that, but apart from that, there's very little information about the software used in it and what these, probably an ASIC is, an application specific integrated circuit, because it has to do quite a few things that the processors of the 80s couldn't do. they didn't have decent analog to digital converters inside them. They do these days, and I use a lot of them. They're so easy to use. But I would have guessed this is an application specific, so it has to have inputs from the seat buckles for the passenger and the driver, and it has to measure 2 different levels. So it might be that they have comparators, but I doubt it. I should think they've got analog to digital converters. So you get 3 different resistances. You get one, which is open circuit if the seat buckle's not there altogether. You get a certain resistance if the seat buckle is there but not buckled, and then the 3rd level is obviously the seat belt buckled. And this system needs to know about it, and it'll put the SRS up, light up if the resistance is wrong. So yeah, you can't just disconnect your seats, for instance, which is connected to the seat belt buckle measuring resistors, because you get your SRS light up, and that's quite often seen that happen where someone's taken a seat out and now the SRS light won't go out again. Yeah, bit of a nuisance, but that's what happens. So yeah, you've got 3 different voltage levels from the passenger and the driver seatbelt buckles. So that's 2 channels going into it. 3rd channel is the occupancy mat for the passenger seat. That has to measure 3 different resistances, just the same as the buckle. That is not there but no one sat on it, and so on sat on it. So 3 different voltage levels. And the last 2 analog channels, of course, are for the pyrotechnic devices, for the airbags themselves, which have a resistance of about 8 ohms or something. Yeah, so that is what I believe that is. That's an ASIC specifically for that, and also used to drive the outputs for the pyrotechnic devices. Now, as I said, it's only 0.1 of a joule needed to power up or to explode an airbag. And we know that because we've got the data sheet of the pyrotechnic devices used. And as I say, it's not volts and amps, it's joules which fire airbags. And these store a multitude more than the 0.1 of a joule required to fire that pyrotechnic device. So, yeah, I do love this device. It's so well made, isn't it? Fantastic thing. I'll give you a nice shot there of the processor, so someone can go away and have a look up what that processor is. Yep, I couldn't find it at all, even though it's a Motorola device. It'll be specific to airbags, and you see it's got a V3 point something on it. That'd be the version number on it. And there again, there's the device TFK, it says on it, and then there's the numbers, and I couldn't find any information on that either. But as I say, I'm guessing that's an analog to digital converter, or application specific for airbags at the very least. So well built, fantastic little resistors, barrel resistors, soldered down, and nothing on the back side of it apart from tracks. It's multi-layer board, conformal coated. Rightio, back to the car. Right, and there we go then. Yep, I found that all quite interesting. Yeah, the module is absolutely fantastic, and it's exactly what an electronics engineer would design for the application, because he'd say, right, I need a processor to keep an eye on everything. Need enough power to keep it going if the battery's destroyed. So I need a couple of big capacitors to keep the thing going. Also, I need 4 big capacitors to store enough energy to fire each of the pyrotechnic devices. And yeah, the processor's not going to be fast enough, so we're going to have to put an ASIC in there. And that's exactly what you get. You get a processor, you get an ASIC, get 4 output channels for the pyrotechnic devices. You get a couple of capacitors to keep the power supply running for as long as possible, switch mode supply. And yeah, 3 accelerometers. Yeah, the main one being the forward and back one, and then 2 at right angles to each other, and 45 degrees to the main one, and that will measure any impact from any direction. And yeah, between them they can decide whether they fire the airbag off or not. That decision will be made by the ASIC and not by the processor. It's just not quick enough. So yeah, a fantastic circuit, so well built, bolted down really hard in a place which isn't going to get damaged in a crash, which is under the center console here. Yeah, it's just a very clever very straightforward device, and then that's really what you want when your safety is dependent on it. Anyway, put the thumbs up if you enjoyed that. Keep commenting. I love the comments. Yeah, keep them coming. I'll always try and answer them as soon as possible. Keep subscribing, and I'll see you next time. Tesla's